Hi everyone, today we're going to go over question 7 of the June 2025 Regents Earth and Space Science exam. So let's get started. So, as always, highlight or underline unknown words, words' meanings, context clues, important details on what a graph, diagram, or text is about, any relationships between things, and circle any task verbs for answering the question. It says another factor climate scientists have identified that contributes to changes in energy flow in Earth's systems is ocean current circulation. So I'm going to highlight factor because it gives me a context clue on what this diagram and the whole text is about. I'm underlining contributions to changes. So these factors contribute to changes in energy flow, highlighting that, in Earth's systems, highlighting that is, and I'm also highlighting ocean current circulation. Part of why I'm also highlighting these terms is because they're also related to the previous question. We've seen factors, we've seen changes to energy flow in Earth systems and ocean current circulation. So this diagram, it seems to be showing me a factor that contributes to changes in the energy flow in Earth systems, which is the circulation of ocean currents. The model, diagram 1 and diagram 2, show some information about circulation patterns in ocean currents. So here's diagram 1 and here's diagram 2. I'm going to highlight that. It's talking about that, and these diagrams show circulation patterns of ocean currents. Point X and Y right here. I would highlight that as well, are locations on Earth's surface. So these are the locations or parts we should be focusing on. So I'm also going around here and seeing what the diagram's about right now. So I see Greenland, and I see Greenland here. I'm going to highlight that. It's next to X, which we talked about before. And let's also highlight some of these labels over here. So it seems that they're labeled. So number 1, sun heats water in tropics. Tropics is a location, so I'm highlighting that. And the sun seems to be heating up water near the tropics, which is around here. 2, water moves north and gradually cools. So it seems that from the tropics, the water is moving north and starts cooling, and it's going towards X, which is Greenland right here. And 3, mixes with cold Arctic water and sinks. So the Arctic is over here, and it seems to be cooling around here and then sinking. So diagram 2 is the influence of fresh water. Once again, it's the same locations. Near the water, it says number 1, increase in fresh water from glaciers, which is coming from X Greenland. So it seems like glaciers are melting and the fresh water is being added to the oceans. 2, addition of fresh water makes North Atlantic less salty, lowering density. So adding fresh water is making the Atlantic Ocean or North Atlantic less salty. 3, warm water can't move north, so because it's so salty, warm water it seems to be, before it was moving northwards, but now since the North Atlantic is less salty, it can't move north, and yeah, so it seems to be the addition of fresh water to the Atlantic, North Atlantic seems to be disrupting this flow of the ocean currents of warm water flowing north and cold water even moving towards the south, towards the tropics. So number 7. What statement most accurately describes the influence of melting glaciers at X on the strength of Earth's ocean currents? So it wants the influence of melting glaciers at X, which we've seen before right here. So I'm going to highlight those. And the influence of melting glaciers at X on the strength of Earth's ocean currents. So the question is asking me what the influence of the melting glaciers are at X on how strong these ocean currents are. And from what we're seeing, it's weakening. So the correct answer, before we talk about that, let's talk about density. So density, it determines if something will float or sink. Density is how packed the matter is within a substance. Sometimes it's really packed together and sometimes it's less packed together. If it's more packed together, it's high density. If it's less packed together, then it's low density. And less dense objects tend to float when the objects or the matter is more spread apart in an object, and more dense objects then tend to sink. Now, the amount of salt that is dissolved in water affects the density of the substance. So, if there's less salt in the water, the molecules or matter that makes up the water is more spread out. There's more space between the water molecules. So, that's less dense. If you have more molecules, such as if we're adding salt, we're adding more molecules to the water, the molecules become more packed together. So that's why it becomes a higher density. So if we're adding salt water, or the ocean water is really salty, that has a really high density. Everything is really packed together in the water. And if we have fresh water that is less salty, then that should have low density. Now, the ocean is typically made up of salt water, right? And near the poles, since it's very cold, the seawater forms large chunks of ice. And as the ice forms, the water is turned into ice, and all the salt is released into the ocean. Because when we're creating ice like this, the ice can't hold the salt. So that's why near the Arctic it's so salty, because the Arctic has so much ice, and because so much water is being taken away from the actual ocean and being turned into ice, the ocean water is actually really salty because so much salt water is left behind. So this causes there to be more salt compared to the volume of ocean water near the poles, and this makes the ocean water near the poles high density. Everything's really packed together with salt and water molecules. Now, um, normally what happens is near the poles like this, we have lots of ice, and this makes the water really cold, really salty because the ice is taking away water, leaving behind a lot of salt, and this makes the water really high density. So in this area, the ocean currents tend to sink because high density, highly packed substances sink. But near the equator or near the tropics, it's really warm, and the water is less salty because we don't really form ice near the equator here. So we're not taking away water and leaving behind salt. It's less salty compared to the poles, and this makes this lower density, the ocean water here, and lower density water or objects tend to rise. And this is how the ocean currents normally move between the equator and poles. Near the equator or the tropics, the warm water rises, and cold, salty water near the poles sinks, and it creates these currents of ocean currents that circulate the heat throughout the globe. Now we've seen from diagram 1 and diagram 2 that now that maybe because of global warming, the glaciers are melting and it's releasing more fresh water to the ocean, meaning the ice is melting. We don't have as much ice anymore, taking away the water and leaving behind the really salty water. We're adding fresh melt water from the ice, and that's causing the ocean near the Arctic or really less salty. And now there's not much of a difference between how much salt there is near the Arctic and how much salt there is near the poles. And this is disrupting the circulation of ocean currents that we were talking about. We need that more higher density and lower density areas for the rising and sinking and the circulation of the ocean currents. If we don't have a higher density area, and both the densities of the water near the equator and the water near the poles are the same or about the same, then the circulation will be disrupted. Let's also check the reference table really quickly, as always, and I see that page 20 shows me the surface ocean currents model. If I go there, I see that here's the North Atlantic, here's Greenland, the Arctic Ocean is over here, and this is also the South Atlantic Ocean. We also have warm and cold ocean currents, and it's showing me the circulation of near the tropics. The warm water is moving, which is in dotted arrows. Warm water is moving towards the north, and cold water, which is what is it called? The bolded arrows are moving towards the south, and we see the circulation happening. If you didn't really understand this, you could go back here and see if you can get more information for yourself. So the correct answer is actually two. If we have melting glaciers, then the influence of melting glaciers at X on the strength of the ocean currents should be that the ocean currents weaken. So more fresh water is added to the oceans near X where Greenland is, causing the ocean currents to weaken. So in the next video, we're going to talk about question 8. That'll be it. Thank you.